What's up, you crazy ninjas? Let's find the minimum and maximum values of f of x here in just a few minutes. We want to first rewrite the square root using a power of 1/2 because this makes taking the derivative a little bit easier to work with. So notice also we have a product here. So with our derivative, that means we have to use the product rule. And if you remember, you start by taking the derivative of the left function, which was x, times the original side on the right, and then plus x times now taking the derivative of this part. When you work out the expression a little bit more, the derivative of x is simply 1, which is nice, times this over here. And then for the derivative of 100 minus x squared to the 1/2, we got this expression here where you subtract 1 from the original 1/2 power, giving you a negative 1/2 after bringing that original 1/2 power out in front. But then you have to multiply it by the derivative of the inside using the chain rule. And when you work that out, on the right-hand side here, after the chain rule, the derivative of 100 minus x squared is going to be negative 2x. And now it's just some arithmetic. I can combine things further. And when you simplify it, you're going to get this expression. And it's going to be nice if you can actually have a single fraction here and a common denominator. So for this left side, what I'm going to do is I'm going to multiply it by 100 minus x squared raised to the 1/2 all over 100 minus x squared raised to the 1/2. And by doing this, it's nice because when you multiply 100 minus x squared raised to the 1/2 times itself, you get rid of that 1/2 or square root altogether, giving you this really nice numerator to work with. And then when you simplify the numerator further, you're going to find now that f prime of x is going to look like this. So what we want to do now for the critical points is we want to figure out what values of x make this f prime of x derivative function equal 0. And by inspection, since we have a fraction, to make it 0, we look at making the numerator 0, right? So I'm going to go ahead and to find the minimum and maximum values that we may have, hang on for a bit because we got to prove it, by setting the numerator to 100 minus 2x squared equals 0. That's just simple math here because when you want to solve this, you're just going to add 2x squared to both sides, and then dividing both sides by 2 and taking the square root, you are going to find that for x equals plus or minus the square root of 50, if you now plug in that value of x into the original f of x function, we are going to find the output or y values at these critical points. So I'm going to do that right now. I'm going to start with the square root of 50, and after plugging it into the original function, don't forget that, when you simplify the expression further here, you're going to have the square root of 50 times the square root of this underneath the root. And when you simplify things further, this is going to give you an output value of 50. Now, is that a min or a max or neither? Well, hang on for a bit. What I'm going to do next is I'm going to take the other value we found from the derivative function for the critical point for x, and that's going to be a negative square root of 50. And when I plug it back into the original function here, I'm going to simplify that further, and this time you don't want to forget this negative right here, but the output's going to be negative 50 this time. So something that is really important, and I don't want you to forget it, is that when we looked at the f prime of x function, remember that we had a fraction. You also have to make sure to find the values in f prime of x that are undefined. Because if you have an open interval that you're working with, you could have critical points there. So because 100 minus x squared raised to the 1/2 was in the denominator, I just want to find out when 100 minus x squared equals 0, because that would mean f prime of x is undefined. And the way to figure out the values of x that make that true is just simple arithmetic, which will give you the values of 10 and negative 10. And what I'm going to do with these as well is I'm going to go back to f of x, just like I did for my other critical points, where I'm going to plug in 10 for f of x, for the value of x. And when you simplify this further, that's just going to simply give you 10 times 0, which is really nice, right? You end up getting a value of 0, and you can do this for yourself. But if you plug in f of negative 10, you're also going to get a value of 0. And normally what you would do here is you would also want to check the domain of f of x itself and check the endpoints to see if you have any values there that could be larger or smaller than the values we got at the critical points. But By inspection, f prime of x's denominator also appeared in the original function. So we already know by inspection, f of x here has a domain between -10 and 10, and it's closed. And because we already checked the ends of the domain at x equals -10 and 10 here, we found out that the output values were 0. So now we have 4 total output values to look at, right? 0, 0, -50, and 50. And it's very clear that these are going to be your minimum and maximum values.